Welcome to my video on solving determinants by cofactor expansion. This is the 7th video in my series on matrix math. And so up until this point we have looked at solving 2 and 2 and 2 by 3 determinants using kind of the standard cross multiplication method. Now I'm going to look at cofactor expansion, which allows matrices to be broken down to smaller submatrices until you get to a 2 by 2. So this would be like if we want to go into a larger, say a 4 by 4 or 5 by 5, or even something bigger. Actually, really you get into computers then, you got to use that. It's too cumbersome, but this allows you in a general sense to do much larger matrices. And so we break it down to a bunch of 2 by 2s is the way we do this. So the first thing we want to do is look at this basic definition. So we define the matrix A, it's just our standard matrix, A, row and column, I and j, n by n, have to be a square. Let m sub j be an n by minus 1 and n by minus 1 submatrix of A obtained by deleting the ith row and the jth column of A. So the determinant of this submatrix is called a minor of A sub j of the matrix. So we're going to break it down. We're getting rid of one row and one column. So first of all, let's look at what this means. Let's just do part of an example here. And so let's calculate what I just told you here, the minors about a row. Let's look at the minors about a row. Okay, first of all, let's pick this first row right here. There's going to be our row. Now we need to do each column associated with that. So that 6402 is going to be our first minor. So M11, that's row 1, column 1, is what's left over, 6402, 6402. Okay, now we take the determinant of that, cross multiply, and that is going to be equal to 6 times 2 plus or minus 0 times 4, just going to be equal to 12. So there's our first determinant. Now let's look at M12, row 1, column 2. So let's see what that is. Row 1, column 2. So now we're left with 2 minus 1, 4, and 2. So if we look at, we've crossed out the green lines, so we've got 2 minus 1, 4, and 2. That's the way we produce a minor. Now let's do a cross multiplication. So that's going to be 2 times 2 minus 1 times 4. And that's going to be 4 plus 4, because we've got a minus sign here. So that's going to be 8. Now let's look at our third minor. We want to do row 1 again because we're expanding about that row and we're doing the last column. So what's left is 2, 6 minus 1, 0. That's not marked out by the light blue. So let's write that out. So M of 1, 3, row 1, column 3, 2, 6, minus 1, 0. Because we were going about the blue line, or blue lines, we cross out the first row and the third column in this case. So let's do our cross multiplication now and see what we get. So we're going to get 2 times 0 minus 1 times 6. And that's going to be just equal to 6 because that goes to 0. Minus cancels here. We just get a 6. So those are our 3 minors and the determinants we calculated. Now we're going to go a little further with this. Now we're going to take that information and we're going to try to figure out how to calculate a determinant. And there's 2 ways of doing this. We can expand about the rows or the columns. So this would be our equation about rows, this about our columns. Let's take a look at this and try to understand what this tells us. This is the summation symbol. It tells you just add a bunch of things up. So j is equal to 1 to n, so there's n number, and j's are going to be our rows. So in our case it was 3, so it's 1, 2, 3. Now this is going to be the multiplicative factor. It's either going to be -1 or 1. This is the element in front of the minor, and this is the minor we just calculated. So there's going to be 3 of those. Now we can do it the other way. If we want to do it about a column, now we're going about k. K is changing, so we can do it that way. And it's the same basic formula. You just need to pick a row or a column. Now this -1 to the j plus k, if you think about that just for a minute, it's either going to be, j is going to be 1, 2, 3, and k is 1, 2, 3, and it's either going to be even or odd. So -1 to an even power is 1, -1 to an odd power is -1. So what you get is for a 2 by 2, you're going to get plus minus, minus plus. For a 3 by 3, because every other number in the matrix is going to be an even or an odd position. It's not to do with the number itself. It's to do with the position in the matrix, where the j and the k values determines this. And a 5 by 5 is just going to be plus minus, plus minus, plus. So that's the -1 raised to the j plus k power for the 3 different, the 2 by 2, the 3 by 3, and the 4 by 4, that goes on and on. So that's what we need to do. We need to sum these minors times the matrix element associated with that minor times this factor right here, which is our -1 or +1. There's the element and there's the minor. So let's go back. Now let's put this all together. Let's go to our example and finish it up and try to make sense of all this. I know it's a lot to it, but if you start doing some examples, which I'm going to do another example in a future video, it should be a little, hopefully a little clearer and a little less confusing. It just becomes rote once you kind of get the hang of it. So hang in there, you'll get there. So there's the matrix that we started with just a few minutes ago. We want to calculate the determinant of that. Now, since we went about the first element, that first element in the row, we have a 1, and since in the plus position, it's going to be a +1. And then we have the determinant of 6, 4, 0, 2, because we blocked out the first row and the first column. Now we add to that about the 3. So in this case, we're going about the 3. That's our second element there. It's in the first row, second column. So now we've got a 3 here, but now it's in the minus positions. Remember, it goes plus, minus, plus. So now instead of the plus sign, it'll be a minus sign. And then 3 is the ace of ij, which is ace of 1, 2 in this case, which is a 3. And times that minor, which is 2, 4, minus 1, 2. So there is our second cofactor. Now we want to go to the third. In this case, we're going about the 0. And as you get to doing these, if you can pick a row or a column that has a 0, you're going to see that's going to make your life a little easier. So I'm just giving you that as an idea for the future. When you're picking your rows and columns, pick one with zeros, things go quicker. So we add this to it. Now we're in the third position, so that it's going to be a plus. So we can leave the plus there. And the element that we're dealing with here is a 0, so we've got a 0 there. And you can see how that's going to make things a lot simpler. So now we cross out the first row, the third column, and we're left with 2, 6, 0, 2, 6, 0, 2. Now it really doesn't matter what that turns out to be because it's got a 0 in front of it, but we're going to do it anyway. Okay, now if we go back and start doing all these cross multiplications, the first one is just going to be 6 times 2, and then it's going to be a minus 0 times 4, so we're not going to worry about that. And it's got a 1 out in front, so that's going to be the first element. Now, minus 3 times, do our cross multiplication here, and that's going to be times 2 times 2, and then minus a minus 1 times 4, and we've already done this. I'm just doing it again, basically. And so that's 3 times, this turns out to be an 8. So it's 3 times 8. And then the last one is 0 times, and that was a 6. So I'm not going to bother to recalculate that because it just goes away. So that's going to turn out to be 12. Minus 3 times 8 is minus 24. That's equal to minus 12. Okay, so that is the determinant of this 3 by 3 matrix right here, using a cofactor and minor expansion about this first row. So I know that was rather involved, but just we're going to do some more examples. In a future video, I'll do another example that'll help kind of solidify this in your mind. Hope you got something out of it. If you did, like, subscribe to my channel, and thank you for watching.